Hey everyone, now that we know the process on how to solve a quadratic equation, let's work on this module working with a quadratic equation that contains a difficult trinomial. So if you recall, when we were doing factoring trinomials, we talked about easy trinomials versus difficult trinomials. And in Ms. Black's world, a trinomial is easy because the coefficient is a 1 in front of the x squared. But if you have a coefficient that's a number other than 1, it made that trinomial difficult to factor. And to me, difficult meant more work. You had two options when we factored a difficult trinomial. I've already taught you how to factor it doing backwards FOIL, which is by trial and error, or I taught you how to use the grouping method. So now let's apply that knowledge and solve a quadratic equation that contains a difficult trinomial. So if you look at your PowerPoint, my quadratic equation is 2x squared plus 9x minus 1 equals 4. We know it's an equation, it has an equal sign. We know it's quadratic, it has an x squared. Step 1 is always set equal to 0. So we have to move the 4 from the right to the left by doing the inverse operation, so we'll subtract 4 on both sides. On the left side, the 4 is a constant, and it will subtract with a negative 1. So now our new equation will be 2x squared plus 9x minus 5 equals 0. Negative 1 and negative 4 would add to negative 5. Now we see it's still quadratic, it has an x squared, and we're ready to factor it, and we're noticing what rule are we going to use? Well, it can't be GCF, that those terms have nothing in common. There's 3 terms there which makes it a trinomial, but it's got that coefficient of 2 that makes it difficult. So now you guys have to choose which method do you prefer to factor a difficult trinomial. I was brought up doing the good old FOIL trial and error. So if you remember, I would label 2x squared as f for the first term. I would label the 5 as L for the last term. And I would label above the 9x the O and the I for the outers and the inners. I know to factor a trinomial, I would put my 2 sets of parentheses. I would start with the first term. What do I multiply to make a 2x squared? And I know that's only one option, 2x times x. So that went first in my parentheses. Then I go to my last term, 5. What are my factors of 5? Well, I only have one option, 1 and 5. When you factored a difficult trinomial, we talked about the placement of those numbers. It matters which set of parentheses they go in. That's where the trial and error came in. So what I did is I put the 1 in the first parentheses and the 5 in the second parentheses. The only way I know if that's right is if I check my outers and my inners, and they have to make the term in the middle, which is a 9x. So if you check my outers, 2x times 5 would be 10x. If you check my inners, 1 times x would be 1x. And yes, if I have a 10x and 1x and subtract them, I would make the 9x in the middle. So that told me my 1 and 5 were placed correctly. Now I get my signs. In front of my 5 is a negative, which means I want to subtract. And I want to subtract to make a positive 9x. So I know subtracting means the signs are different. And because I want a positive 9x, the bigger term gets the positive. Now, with the bigger term, it's the outers and inners. The outers were 10x, the inners were 1x. So the 10x is bigger, so that's why the 5 gets the positive and the 1 gets the negative. So 2x squared plus 9x minus 5 equals 0 factors to be 2x minus 1 times x plus 5 equals 0. Now, if you go over to the other side, that's not the only way to factor it. So look at my other example on the PowerPoint. Okay, when I got my trinomial in the correct descending order, I could also use grouping. If you remember to factor using grouping, you take the first coefficient, the 2, and you multiply it by the constant, the 5. So 2 times 5 is 10. And what you did on your side of your paper when we did grouping is we list the factors of 10, which would have been 1 and 10, 2 and 5. How we decided which factors to use, again, those factors have to make that middle term 9x. 2 and 5 cannot make a 9x, but 1 and 10 can. So we know we're going to use the factors 1 and 10. So when you do grouping, you write the first term, 2x squared. You write the last term, negative 5. But you're going to replace that middle term. We're not going to write 9x. We're going to write using the 10 and the 1. And we know 10x minus 1x would be the 9x. So that's why now I have 10x minus 1 in the middle. Now I have 4 terms. And that's the thing about grouping. Grouping needs 4 terms. And then we group the first 2 together and the last 2 together like Noah's Ark grouped the animals. When we do grouping, we're doing the GCF rule. So if you look at the first 2 terms, 2x squared plus 10x have in common a GCF of 2x, so I pull that out. That leaves me x plus 5. My last 2 terms, negative 1x, negative 5, have in common a GCF of negative 1. So when I take that out, factor it out, I'm left with x plus 5. If you remember, we know we did grouping correctly because our parentheses, x plus 5, are the same. But now we have to rewrite that statement because our statement needs to be 2 binomials connected by multiplication. So if you look, we have an x plus 5 in common. So we have our x plus 5 in one set of parentheses, and then on the outside would be the other set of parentheses, the 2x minus 1. So what I want everybody to understand is when we're solving quadratic equations and we have a difficult trinomial, it doesn't matter if you factor that difficult trinomial doing trial and error, backwards FOIL, or you factor it doing the grouping method. We're both going to get the same expression. If you look, now we both have the 2 linear equations. 2x minus 1 equals 0, x plus 5 equals 0. And now we'll solve each. So on the first linear, we'll add 1, and then we'll divide by 2, and we'll get our expression being x equals a half. You also could restate that as a decimal as 5/10. We would accept either answer. The other linear equation, we would subtract 5, and we would get x equals negative 5. So your 2 solutions are x is a half, or you could write 5/10, and x equals negative 5. Let's go to the whiteboard and practice some more.